Okay, so in this video, we're going to be talking about solving quadratics by factoring. Now, in order to do this video here, you have to know how to factor a quadratic. So if you do not know how to factor a quadratic, I have videos on how to do that. So go ahead and check the links below. I'll link those videos, that way you have access to that content. But assuming you know how to factor, let's go ahead and talk about how we're going to factor these quadratics and solve them. So the first step that you want to do when you're solving a quadratic is set it equal to 0. Now, if you don't see it equal to anything, by default, it's going to be equal to 0. So if you wanted to, you could put equal to 0 here, that's fine. But that's your first step. Then your second step, can you pull out a greatest common factor between your terms? So for example, do I have a greatest common factor between this term, and this term? And the answer here is I do not. Okay, so then I go on to my next step, which is going to be the AC method. So you're going to hear me talk about the AC method a lot in here. And that is when you have a quadratic in standard form, which is ax squared plus bx plus c. I simply want to multiply a times c. So I can clearly see here that my quadratic is in standard form, right? So my a value here is going to be 1, right? That's my a coefficient. And then my c is going to be negative 18. So when I do a times c, I get negative 18. So now you have to come up with two numbers that when you multiply will give you this negative 18, but add up to your b coefficient, which in this case here is going to be negative 7. Okay? And you can start with a list of numbers if you'd like. So for example, I'll start with 9 and 2. Okay? When I multiply 9 and 2, I get positive 18, not negative 18, so that's not going to work out. However, if I make the 9 negative, when I multiply them, I get the negative 18, and then when I add them, I get the negative 7, my b, right? So this is good. I can go ahead and put this right in factored form, and since a is equal to 1, I don't have to do any factoring by grouping. Again, I'm going to put it right in factored form. So for example, you're going to write x minus 9, and then you're going to write x plus 2, okay, in parentheses, and then again, all equal to 0. So it doesn't matter the order that you're writing these factors in. So for example, I could have written x plus 2 right here, and then I could have written x minus 9 right here. It doesn't matter because again, you're multiplying and you can multiply in any order. So the order in which you're writing these factors, it doesn't matter, okay? So right now we have the quadratic completely factored. Now this is the easy part. All we have to do is solve it. So you take each one of your factors, you set them equal to 0, and you solve. So for example, this is one factor. Here's another factor. I'm going to set them equal to 0 and solve. So there's one. Here's the other one. So when I solve this one here, I get x is equal to 9. When I solve this one here, I get x is equal to negative 2. And you're done. So again, what is this telling you here? This is telling you where this quadratic is crossing the x-axis, right? Again, that all goes back to setting it equal to 0 up here. What are you actually setting equal to 0 there? Well, you're setting y equal to 0. And so if you think about it, any curve that you have, whenever it crosses the x-axis, y will always be equal to 0. So by default, by setting this equal to 0, you're essentially solving for the values where this is going to be crossing the x-axis, or in other words, we call this the zeros, right? So you could write it like this, that's fine. X is equal to 9, x is equal to negative 2. But you could also write it as a point. So for example, one solution would be 9, 0, and then the other solution would be negative 2, 0, right? Because they're actually points where, again, this quadratic is going to be intersecting the x-axis. All right, so that's our first example. Let's go ahead and check out another example. So here's our next example. Now on this one here, you have to make sure that you set it equal to 0. That's always step 1. So I have to take this positive 15 and I have to move it over. So I get x squared minus 2x and then minus 15 equal to 0, right? And then from here, can you pull out a greatest common factor between your three terms? Well, this one, and this one, they don't have anything in common, so I can't. So I'm simply going to do a times c. So a times c, when I do that, I get negative 15, right? That's 1 times a negative 15. So I need two numbers when I multiply that will give me negative 15, but add up to negative 2. Start with 5 and 3. So 5 and 3. I know that one of them is going to have to be negative. So if I make the 5 negative, when I multiply them, I get negative 15. And then when I add them, I get the negative 2 right here. That's what I need. And since a is equal to 1, you can put it right in factored form. So for example, you're going to write x minus 5, and then you're going to write x plus 3, and again, all equal to 0. So you have two factors here. Take those two factors, set them equal to 0, and solve. So you get x minus 5 equal to 0, and then you get x plus 3 equal to 0. When I solve them, I get x is equal to 5, and then I get x is equal to negative 3. And so again, that's fine. You can leave it like that. But if you want to write it as a point, it would be 5, 0, and then negative 3, 0, right? And this one is now done. All right. Okay, let's try another example. This time you're going to have to factor by grouping. Okay, so here's my next example. And your first step, set the quadratic equal to 0. So right here, this one's easy. I don't have to move anything. Just set it equal to 0. Okay. Now from here, can you pull out a greatest common factor between your three terms here? Well, this term and this term, they have a 4 and an x in common. But this term here, it doesn't have anything in common. So unfortunately, I cannot pull out a greatest common factor here, but it's not a big deal. We're still going to do the AC method. There's going to be one more step at the end though that you're going to have to take care of. So if I do the AC method here, I'm going to do A times C, and that means I'm going to do 4 times negative 15. That's going to give me negative 60, right? So I'm going to put negative 60 here. So I need two numbers when I multiply that will give me negative 60, but add up to positive 4. And so let's start with 10 and 6. So 10 and 6. So when I multiply those, that will give me positive 60. I need to make a negative 60. Well, let's go ahead and make the 6 negative. When I multiply them, I get the negative 60. And then when I add them, I get the positive 4 right here, my B, right? So this will work out. Now, unlike the other problems, I can't put this right in factored form because my A value right here is not equal to 1. The only time you can put it right into factored form is when A is equal to 1. If A is not equal to 1, like we have here, you have to do factoring by grouping. And it's not a big deal, but it is an extra step that you have to do. So to do that, you simply rewrite it. So I'm going to write 4x squared. And when you factor by grouping, you're essentially going to be breaking apart this term right here. So this bx term, okay? Again, I'm referring to a quadratic in standard form, ax squared plus bx plus c. So this term right here, we can refer to as bx, right? So I'm breaking that apart. And when you break that apart, you're going to use the values that you came up with, 10 and negative 6. So I'm simply going to write here plus 10x, and then I'm going to write negative 6x, and then finally I'm going to write negative 15. And then all equal to 0. So it doesn't matter the order that you're writing these in. So I could have written negative 6x right here if I wanted to, and then I could have written positive 10x here. It won't matter, okay? The order does not matter. So you don't have to worry about that, but you can see that 10x minus 6x will give me 4x. And so from here, what you want to do, you want to go ahead and group together your first two terms. And then you want to group together your last two terms. And from here, you pull out a greatest common factor for each set. So looking at my first set here, I can pull out a 2. I can also pull out an x. So I'm going to pull out 2x. In parentheses, that will give me 2x and then plus 5. Looking at my second set here, I can pull out a negative 3, right? And that is it. So I can pull out a negative 3. And that will leave me with 2x and then plus 5. Okay? And then again, this will all be equal to 0. So you can see what happens here. I end up having something called a common factor. This factor is the same as this factor here. Okay, so that's your confirmation that you did it correct. If those factors are not the same when you're doing factoring by grouping, you need to go back and rework it because you did something wrong. But that's my confirmation that I did it correct. So now all you have to do is write your common factor one time, 2x plus 5, and then write the outside values together, 2x minus 3. So I'm going to write here 2x minus 3. Okay, all equal to 0. And so from here, you're almost done. You have a factor here, set them both equal to 0 and solve, and you will get your answer. So doing the first factor, I get 2x plus 5 equal to 0. When I solve that, I have to move the 5 over and then divide by 2. So that will give me negative 5, right? So 2x is equal to negative 5. And then dividing by 2, I get x is equal to negative 5 all over 2. And then doing the second factor, I'll go ahead and do it up here. You're going to get 2x minus 3 equal to 0. I'm going to have to add that negative 3 over. So 2x equal to positive 3. And then finally, dividing by 2, you get x is equal to 3 over 2, right? And then from here, we can write it as a point. I can say 3 over 2 and then comma 0. And then I can use negative 5 over 2 comma 0. This is done, right? So here's my answer. Okay. All right, let's try a few more examples. Okay, so here's my next example. This one here, you want to go ahead and set it equal to 0. So setting it equal to 0. And then from here, can you pull out a greatest common factor? And you can't. But again, we're going to do the AC method. But this will be another problem where you have to do factoring by grouping. So if I do A times C, I get 5 times 6. That will give me 30. I need two numbers when I multiply. That will give me 30, but add up to my 17. Well, that's going to be 15 and 2. So 15 and 2. Now, A is not equal to 1. So I have to go ahead and do factoring by grouping again. So I'm going to say 5x squared. And then again, it doesn't matter what value you grab here. You can grab the 15. You can grab the 2. It won't matter the order. You'll get the same answer in the end. But I'll go ahead and grab the 15. So I'm going to write plus 15 and then put the variable, so x, and then grab the other number, plus 2, and then x. And then finally, I write plus 6, and then all equal to 0. From here, I want to go ahead and factor by grouping. So I group together my first two terms, and then I group together my last two terms. And so what can I pull out between that first set? I can pull out a 5. I can also pull out an x. That will leave me with x plus 3. Looking at my second set, I can pull out a positive 2. So plus 2, and that will leave me with x plus 3, and then all equal to 0. So did I do it correct? And the answer is I did, because my common factor is the same. That is your confirmation. So from here, you write your common factor one time, x plus 3, and then you write your outside values together, 5x plus 2. So 5x plus 2, all equal to 0, and you're almost done. Solve your factors here, and then you're done. So x plus 3 equal to 0. That will give me x is equal to negative 3. And then solving the other factor, I get 5x plus 2, all equal to 0. And we can do this all in one step. I'm going to have to go ahead and subtract 2 and then divide by 5. That will give me x is equal to negative 2 all over 5, right? And so finally, I can write it as a point. So I'm going to say here, negative 3, comma 0. And then the other 0 here is going to be negative 2 over 5, comma 0. Okay, so again, we can refer to these as the zeros. That's another word that you can use when you're solving a quadratic. You're simply just finding the points where, again, this curve is intersecting the x-axis, right? Or in other words, you can call them the zeros. All right, let's go ahead and try one more example. So here's my last example. Now this one here is not equal to 0. We have to go ahead and take this positive 3x and positive 1 and move it over to the left-hand side. So I'm going to say here 18x squared, and then minus 3x, and then minus 1, all equal to 0. From here, can you pull out a greatest common factor? And you can't. So again, I'm going to do the AC method and then go from there. And again, this is an 8 here. All right. So I'm going to do A times C. That will give me negative 18. So two numbers when I multiply, that will give me negative 18, but add up to negative 3. Let's start with 6 and 3. I know that one of these numbers has to be negative, and that is going to be the 6. So I'm going to put negative 6 here. So again, when I multiply them, I get negative 18. And then when I add them, I get negative 3. Now, A is not equal to 1 here, so I have to go ahead and factor by grouping. So I'm going to rewrite it as 18x squared. And then again, grab any value. It doesn't matter. I can grab the negative 6 or the positive 3. It won't matter. I'll go ahead and grab the positive 3 here. So plus 3x, and then minus 6x, and then minus 1, all equal to 0. From here, I'm going to factor by grouping like we've been doing. So group together your first two and then your last two. And then what can I pull out between my first set here? Well, I can pull out a 3 and also an x. So 3x, and then I'll have 6x plus 1. And then what can I pull out between my second set? Well, remember, you want to pull out something even if it's a 1 or a negative 1. In this case here, I can pull out a negative 1. That will leave me with 6x plus 1 equal to 0. And then from here, I have my confirmation. My common factor is the same, so I did it correct. I'm going to write the common factor one time. And then I'm going to write my outside values together. 3x minus 1 equal to 0. So this one here, we're going to go ahead and do it in our head, right? I have my two factors here. I'm going to solve both of them. So solving this factor right here, you're going to get x is equal to negative 1 all over 6, because again, I have to minus 1 and then divide by 6. Doing my second factor, I'll have to add the 1 and divide by 3. That will give me x is equal to 1/3. And then finally, we can write it as a point. So I'm going to say here -1/6, and then comma 0. And then I can say 1/3, comma 0. There it is. Those are my zeros, right? And so that is it. That is how you can solve a quadratic by factoring. The takeaway here, just always make sure that it's equal to 0. If it's not equal to 0, you cannot factor it. You have to make sure that the quadratic is set equal to 0 first, and then you can go ahead and factor. Also, make sure that you're always trying to pull out a greatest common factor. In this video here, it didn't matter because none of our terms had a greatest common factor at the beginning. But sometimes pulling out a greatest common factor can make the problem easier because it can make your a value equal to 1, and then you don't have to do factoring by grouping. But with all that being said, that's going to do it. So I hope that you found the video helpful. I hope that you gained something from it. If this video did in fact help you, if you could just go ahead and give it a thumbs up, that'd be greatly appreciated. Also, make sure you subscribe, that way you get more math videos in the future, and I'll see you in the next one.